Hello everyone. My name is Hyen Jay Lee, and this is my lab report for lab number 1. Let's get started. So, to give a brief background of the experiment, the plan was to determine the force exerted by one U-tape or another when they are measured from a distance apart. We will be using two charge tapes to approximate the following: the number of excess charge and the number of atoms that gave up electrons. So these are the physics principles that we will be using throughout this experiment. The transfer of charge through contact, using the second law, which is F force is equal to mass times gravity. Electric field equation, which is equal to K times Q over R squared, with R hat. And the electric force equation, which is equal to the charge of the electron times the electric field. And I will also explain how these principles are used throughout the experiment and the calculations coming up. So to give a brief experiment observation, the tapes will repel one another when placed against each other, which show that they are the same charge. The tape attracted the negatively charged pen, which show that the tape is positively charged. To give a brief data measurement throughout the experiment, the length of the tape was approximately 20 centimeters, which is equal to 0.2 meters. The mass of the tape, using the assumption given in the lab, is equal to 2 times 10 to the power of negative 4 kilograms. The distance between the two tapes was around 1.2 centimeters, which is equal to 0.012 meters. These are the calculations done throughout the experiments, and the ones we implemented in the closed script coming up. The charge on tape B, since tape B is floating to the charge of tape A, this means that the magnitude of the electric force and the magnitude of the gravitational force are equal to each other. And we can find the charge on tape B by using this assumption. So mg, which is the gravitational force, is equal to the electric force, which is K times Q over R squared. We isolated the Q, so Q is equal to square root of mass times gravity times R squared over K. And we simply plug in the corresponding numbers for each of the variables, and the result is around 5.6 times 10 to the negative power of negative 9. And the number of excess electrons on tape B can be found using the charge of tape B over the charge of the electrons, which we know the charge of the electron is 1.6 times 10 to the power of negative 19, and we know the Q from which is equal to 5.6 times 10 to the negative power of negative 9, and that came out to be 3.5 times 10 to the power of 10. Now, the atoms on the to find the atoms on the sticky surface, we have to multiply the length of the tape times the width of the tape, and over length of scale of atom powered by 2. And as you can see, that is equal to 0.2 times 0.012 over 1 times 10 to the power of negative 10 power of 2, which came out to be 2.4 times 10 to the power of 17. The ratio of excess electrons to the number of electrons, that is simply just number of excess electrons over the number of atoms on the sticky surface, and these were all found beforehand, 3.5 times 10 to the power of 10 over the number of atoms, which is 2.4 times 10 to the 17, which is around 1.45 times 10 to the power of negative 7. Now this is a closed group model done through to model this experiment. Now we have the constants kg, length of scale of atom, and the charge of electron, and we have the initial values, the mass, the r, the length of the tape, and the width of the tape. And we initialize the location using the vector equation particle for, and we have the calculations below, which we follow the same procedures as the calculations that we showed beforehand. And the results were equal to the hand calculated and the closure calculated. To finally answer the final questions, what if electrons had a positive charge and protons had a negative charge? And my answer is the result will not vary. Why is it important to handle this charged tape as little as possible? What happens when the charge comes in contact with your hand or the other object? This refers back to the physics principle that we talked before, the transfer of charges. The charge can easily be transferred when we touch the tapes, which would change the charge of the tapes and contaminate the experiment. That is why we have to be it is very important to handle the charged tapes as little as possible. And that is it for my experiment and my lab. Thank you very much for listening.